Okay guys, so in this video we are going to talk about securing our JavaScript applications from issues coming from the server. So let's get into it. Now, basically what we're going to talk about is the most common reason for regression bugs in JavaScript and how this issue occurs and how we can solve this in a fairly nice manner. And this is just me, of course, sharing some experiences from working a few years with these sorts of issues. But let's get into it. So one of the most common reasons for a web application to break is that the page on, like your JavaScript on the page, is for some reason throwing an error, like a user interacting with the page, or if you do an AJAX call or something fails with your JavaScript, and now the page is no longer connected to your JavaScript listeners or something of that nature, and all of a sudden the page is completely broken, or at least the functionality that you're looking for is broken. So in an SBA like React and Vue and Angular and stuff of that nature, this is even worse, because if you throw an error with JavaScript, you can actually find yourself in a situation where the page doesn't actually render. And it's very tricky to test all these things that could go wrong in JavaScript, and it's actually very common that these sorts of issues occurs. So what usually happens is that you are referencing some value that you expect to be something that it's not. For example, you're trying to grab a property of an object that isn't there, or you're trying to do a toString operation on something that can't be converted, or you're assuming that something is a number when it's actually a string. Like, there's all kinds of issues that you can face. So it's very important that you can, what I like to call, to be able to trust the data that you are operating on. So the way that I solve this issue, where you have all these possible reasons for as to why JavaScript can throw an error for at any given moment, basically, is to create a situation where you can only throw an error if you yourself choose to throw that error. Now, what do I mean by that? I mean that if you explicitly say, as the programmer, that in this scenario, if this happens, let's throw an error. But the code, you should at no point have code that can involuntarily throw an error. And the most common thrown error in JavaScript, just in general, is could not find undefined of something something. You tried to get something that is not there. That's the hands down the most common reason for JavaScript to throw an error. So if you can solve that issue, you actually solve most of the bugs that are out there on the internet. So the mindset that I want you to take away from this little tutorial of mine is that if you do server-side work and a user you get data sent to your controller, do you just trust that data? No, of course not. It's extremely bad practice for security reasons to just receive data and not validate it. A server always validates the data. A server always needs to specify what data it is expecting, because otherwise you can't continue with the program. Now, the question I want to ask you is, why would we treat our JavaScript differently? Why not have the same mentality for JavaScript? It's not for security reasons, but it's because we want to be able to be sure that our program will always work, regardless of what happens on the server. Because one of the main reasons for so-called regression bugs is that you change something on the server, and then for some reason you forget to change things that are depending on that change. And that happens in JavaScript quite a lot, like especially in typed languages. I mean, in a typed language on the server, it's so easy. Okay, you make a change to one of your models, and now you get a compilation error in all the places where you have to update that value. Easy peasy. But if you have a JavaScript application, you don't have that. You now have to go through the code and do a string search or something like that to figure out, all right, where are all my changes? Like, where are all the places where this value has a dependency? And this is very tricky in a large code base. So how can we mitigate this problem? How can we figure out a way to have the same type of mentality that server-side developers have when they get input data? Well, I'm going to show you how I solve this problem, and this I can only speak for myself. This works very well, but let's dive into it. So first and foremost, we have our Express server. This is what it looks like. We have some input data here that we are going to touch on in just a moment, and 3 different endpoints. We have this little index.html file that just has a 2 JavaScript files basically, and these are the things that we are going to touch on. So here's our application in its entirety, and I'm just scrolling through the code so you can just see the code. So the application is a dirt simple little application. It simply prints out my users and foo, bar, bas, and a number or an age, and that's the entire application. So let's walk through this code. I have some comments, out-commented code here. We'll touch on that in just a moment. So what we're going to do now is that we're going to go to our server and grab whatever is on users-v1, so version 1 of this API, right? And then we're going to parse that, and that's going to be, we are assuming in this scenario that this is an array of users. And then basically we have this little function called myUsers that takes in a bunch of users and basically just declares a user string. And ignore this map for this filter for a moment. Then we map over all those users and we convert all of the users into a string, which is this list item here with an h2, which is holding the user name, an arrow, and then the user age. And then finally down here we are doing a join on this array of user strings so that we can concatenate all these strings together. So we end up with a string of all these list elements. We create another string, or we use a string template like this, and then finally we use this function in this call to the body basically. So basically what we're doing here is that we are rendering out using string templates this little list here. That's all that's happening here, right? So let's look at our input data in this scenario. So our input data is users. So on version 1 of this API, we have this users array. So we have 3 objects coming in, and as you can see, this works fairly well, because if we look at our example here, so we take these users, we loop over all the users, and we simply extract the values from these users. Easy peasy, and we're ending up with this. But what happens if we change to version 2? So let's change to version 2, and let's see. Okay, what happened here? Alright, let's look at the network request. So here we now see that, alright, in version 2, so in theory somebody made a change for whatever reason, and now we have a null value in our array. For some reason there's a null value. We don't know why. If you go to the server, as we can see, there's an undefined here. So in version 2 of our users, there's like a garbage value for some reason. Now, this is actually very common. This is extremely common that something like this will happen. Now, even this little implementation here, I mean, if I wanted to perfect this even more, I wouldn't assume that this was an array. I would try to check that, make sure that this was an array, but for simplicity we are just assuming that it's an array. But let's try to fix this problem, right? So the obvious thing here is to just do this, to create a filter function that simply checks if a user is a truthy value. If we now refresh this page, we can see that it works, because what's happening now is that we didn't assume that the data that was coming into the coming in the array was going to have the same shape. So we were just filtering out everything that could be a falsy value. Now it could have been any like any garbage value. It could have been a string. It could have been all kinds of stuff. So yeah, but you know, this kind of works. Like if you were working and you saw a bug like this, it would be a reasonable fix for you to just put a filter like that, or to fix it on the server. But remember, it's better for you to just do like to put some guards up ahead of time when you're doing JavaScript development, instead of waiting for the bug to actually hit your system. So we're done now, right? Well, no. Let's have a look at another example, like at our final example here, and just have a look at what's happening here. All right. So what's going on here? So here, oh, okay, we have some other weird values here. Let's look at that. So now the name has changed from just being a simple string, And in version 3, a name is now an object holding a first and a last name. And in another user, there's just a first name, there's no last name. And then there's another weird garbage value here. So this is actually a very common thing. Like usually you start with this name. I've seen this 100 times. You start with like a name is a classic example of a model or a property on a model on the server that can change from just being a string to being an object. Because if you think about it, yeah, sure, a name can just be a string, but a name can also be made up of different parts depending on your use case. And these are the sorts of changes that can just they don't start out the system as being in this shape. They start out being very simple, and over time and over the years, they become that you develop new use cases and you develop new needs and changes to your model. And in order to mitigate this sort of problem, where you can see here, I mean, it wouldn't be easy for me to create some type of filter function or something like that, or try to guard against all of this diversity in our model. Now, this is of course bad practice, that like our server-side developers should not be doing something like this, but it actually happens quite often. So what I do is this. Let's uncomment this little thing here, and let's change user like that to incoming user. And let's refresh that, and now we see that, hey, all right, everything seems to be working. Okay, there's an undefined there. Let's investigate that for a moment. But what's happening here is now that, all right, I'm taking in the user, and then I have this constructor function here. And this is where the magic is happening. So on the server, what you usually have, especially in a typed language, is that you have a model of some sort. That model has a shape. It's a data shape that you expect your data to be in. The first thing that happens when you send a post request to a server is that you map that data into some type of model. Like, that's usually how it happens. If you are creating some type of user or something like that, you take all that data, the strings, the name, and like the emails and all that stuff that's being sent to the user, and you put that in a model. And the reason why you want to be able to do that is because if you have your data in a model, you can now assume things about that model. In JavaScript, we don't have this practice, and I argue that we should. So let's look at the incoming user. So the incoming user is this thing here. All it's doing, all it is a simple function with all, like, this is the entire logic. So let's just walk through that very quickly. So we have a function called user that basically that is returned, and all it does is that it returns this shape. Because this is the shape of the data that we are expecting. We are expecting our user. If we look at our logic here, the only expectation we have on our logic is that the user should have a name property and it should have an age property. This is our program. This is the JavaScript part of our application, and our JavaScript assumes that there's an age property and a user and a name. That's what we're assuming. So we create a object, a default object that actually holds this information. That's what we're doing. And if we go down to this incoming user object here, so here, this is the thing that we are exporting to our application here. This is this function here. So what's now happening is that, all right, we take in what we think is an incoming user. We don't know that it's an incoming, what it is. We have no idea. This could be anything, but we just assume that, like, we want to be able to trust that whatever is happening when, like, whatever we return is a safe data structure. In other words, we know that in the rest of our application we need the name and the age. We already know this, and that's why we want to be able to trust that whatever is coming in is going to have the name and the age. We need it to be an object with name and age. All right, it's clear so far. Awesome. So we create a new user. This is now holding our default values. So the first thing we do now is that we check if the user is in the correct format. So we check if incoming user is a truthy value, and we check that the incoming user has a type of an object and that it's not an array. Now we've done our type checking. If this passes now, we know that the incoming user has the correct shape. But if the user is not in the correct format, then we simply log out of warning. if we look at my little console here, look at this. So when I refresh this page, all that happened, like our application is still working, but we have a bunch of warnings. Okay, so there's a missing first and or last name. Name should be a string or an object, first, last. Age should be a number. So we are now logging out some warnings about what we expected, but we're still returning the default value. So what's happening now is that our application will keep on working, but we're logging out the issue that we found with the input data. So this now becomes very easy for a developer to debug. What's going to happen now is that a user is going to see the application, or you're going to see the application. Maybe you even have some error tracking system that picks up these warnings, and the application will work, and you will be notified, and then you can rectify the problem. But if you didn't do something like this, the whole application would break, and it would stay broken until you were able to fix it. So this is why we're doing this type check. And then we do maybe set name. So what do I mean by maybe set name? Let's look at maybe set name. So it takes in a name and a user, and it checks that the name is in the correct format. So it checks that it's going to be equal to a string, or it should be equal to an object, because remember, name is, as I said, it's a classic example of it starts out like a string and then it becomes an object, or something, or vice versa. It's something of that nature. It's one of those properties that can so easily change shape. And I just wanted to illustrate this as a very, trust me, this is a very common situation where a name means it starts out as a string and becomes an object. Just trust me on this one. So what we do then is that we check if the name is in the correct format, and then we have this function called name to string, which is going to override the user's name, this default value. So if we find a name and we can format it, we're going to override this missing names property with whatever this function returns. So let's look at that function. All right, so it takes in the name, and it checks if the name is a type of string, then it simply returns the name. If the name is falsy, or it's not of type object, or that it's a type, basically it's an array or something of that name, of that nature, we're simply going to log out a warning and return missing name. That's it. If we don't have a first name or we don't have a last name, we log out this warning, and then we simply return at the end of it just this shape here. That's it. We're simply returning the first name and the last name as a string, because what we're doing here is that we are always converting the name to a string. Because if you look at the logic, if this was an object, this would make no sense. We would be logging out, we would be printing to the screen, or we would put in our DOM just object as you saw earlier, and that's not the effect we want. Like, our use case for name is that name needs to be a string. That's why it can't change, and if it changes, our JavaScript breaks. So in our incoming user, all we're doing is that we make sure that name is always going to be a string. That's all that's happening here, right? So maybe we set the name, maybe we don't. And then we have maybe set age, and you can probably guess what that's going to do. It's basically the same thing. It takes in an age and the user. It simply checks if age is a number, and if the user has if the user age is in the correct format, we simply override the default age, which is this missing age property here, and that's it. And otherwise, we simply log out age should be a number. That's the whole. That's all we're doing. And then we return the user. So by approaching the problem this way, by creating this in-between layer, that's why I want you to take away from this. By creating this single constructor that takes in the input data that is coming from the server and validating all that data, and if it doesn't have if the input data does not have what we are looking for, we simply return default values and log out warnings or errors or something like that to indicate that we are missing something, that something came into our system, into our JavaScript code that we were not expecting. You have now created a program that can at no point break, because you can always, as long as you can trust what is being returned from the incoming user constructor, you're fine. you don't have to do any type of validation checking further down in your program because you have already done it on this line. And this is extremely powerful because as long as this function returns default values that you can trust, your program will be able to deal with any changes on the server. Even if we change all of this and we create completely different data structures, your JavaScript will still continue. It will still work without breaking the experience for your users. So, to summarize, use the same mentality for your JavaScript input data, the stuff that's coming from the server, as you are like the same mindset as you use on the server, and you will be able to write much more sustainable and robust JavaScript. And I hope you have a great day.